Hey, this is Billy Atkins with CPSC 2100. We're going to do problem 2.4. I went ahead and put in some of the variables, balance equal 5,000, annual interest 0.18, monthly interest is just equal to the annual interest divided by 12, the basic stuff, but we're going to be looking at using an upper and a lower bound with finding the interest and making it run a lot faster, essentially, for finding that kind of data, getting like the in between using a bisection. So anyways, we're going to go ahead and start with a lower and an upper bound, and we're going to set our lower to the balance divided by 12 for each month. And then the upper is going to equal the balance times 1 plus, oops, wrong way, 1 plus interest. And then we're going to square that by 12 and divide that by 12. Okay. And then we will, let's see, we're going to make an epsilon, which essentially helps with rounding errors. So we're going to set that 0.1, and we're going to go ahead and set a minimum payment to pay is going to equal the lower, no. I mean, I guess it doesn't matter, but upper plus the lower divided by 2, which is just getting the average. And we're going to define a method, and we're going to define recursion because we are using recursion for this to get the payment. And we're going to set a month. We're going to define a balance. We're going to have a minimum payment. And then we're going to have a monthly interest. And we're going to run a while loop inside this. And we're going to do while the month is less than 12. We're going to add 1 to each month because we're going to run a counter on it. We want it to count 1 until we reach 12 so that it happens for 12 months. And we're going to take the remaining balance. We're going to set that equal to the balance minus the minimum payment. So every time it occurs, it subtracts from the minimum payment that's due to the credit card. And then we're going to set our balance equal to the remaining balance. And we're going to add it to, we're going to add the remaining balance. Oh, goodness. We're going to multiply by the monthly interest, which is going to give us our monthly interest rate added onto it, which we will use for the credit card. And after all that occurs and everything, we will go ahead and return balance. And I think this needs to be, yeah, so that's not happening, but that, yeah. Because we want it just to run and for it to just return. We don't need that inside of the while loop there. We're gonna go ahead and define low as the lower payment. And then we are going to define high as a higher payment. And we're going to run another while loop actually. So we're going to go ahead and say, while this is true, and use that Boolean, while the month is equal to 0. the temp balance, which is just kind of a placeholder. Or you could also say it's kind of like almost like we're starting and everything. The temp balance. We're gonna run recursion. So it's gonna run this method that we're defining up here while this is true. Then the month. Really? Actually, let's just go ahead and oh crap. Where's the undo? Oh well. I meant to copy. No, there we go. Balance, interest. Okay. And we'll run an if statement. If the temp balance is less than 0, low is going to equal the minimum payment. If the temp balance is greater than 0, the low is going to equal the minimum payment. Then else the high is going to equal the minimum payment. And then while all that is true, and after all that occurs, the minimum payment, actually, hold up, actually, no, we have to define the minimum payment actually. So we're going to do minimum pay. Minimum payment is going to equal the low plus the high divided by 2. And then minimum payment is going to equal, we're going to actually use this round method here. I found it easier to use this over using the F. And let's see. So minimum payment, we're going to round to the second decimal place. And then we're going to print. Right. I'm going to change it to a string. Else. Oh. Hmm. Oh, I did. Oh, oops. That actually needs to be. See. I think I have that. Or I'm let's see. Incursion balance. is equal remaining balance plus remaining balance times. Oh, yeah, that's supposed to be monthly interest. Let's see. It's taking a while. Actually, hold up. I think I forgot. I think I forgot that I need to. Hmm. If the maybe we can take the absolute value. If the absolute value is less than or equal to epsilon, which is that placeholder. Right. Hmm. This is running too slow for what that's supposed to be. Yeah, it's supposed to be. Maybe that's supposed to be lower, and then let's see. Definition of the month long. Month adds one. Remaining balance is equal to the balance minus the minimum payment balance. Hmm. Keyboard interrupt. 1 month is less than 12. Oh, maybe that's in a weird place. I shouldn't. Hmm. Two. No, so- Define the recursion. Hmm. Oh wait, hold on. It's supposed to be higher. That's why that wasn't working whenever I had it here. Hold on. Oops. Oh my goodness. No. Why does it keep slower? There we go. Yeah, I was about to say it was supposed to be defined there. Oh, I had that backwards. High is equal high, lower is equal to low. Hmm. No, this is supposed to be higher. And then we're changing, yeah, for this. So why is the minimum payment? I have higher defined there. Oh, why did I end that library? I need that. Epsilon. Epsilon is 0.01. Minimum payment is higher plus lower divided by 2. Hmm. That should break there. F absolute value month true equals over. Higher is not defined. Oh, I didn't change this one up. That's why. I don't should have started from the ground up. Here we go. Okay. Finally, after noticing all the tiny errors, we have a minimum payment of 451.63, which is correct. Balance of 5,000, annual interest of 0.18, monthly interest is the annual interest rate divided by 2. I need to pay attention to setting it as upper and lower whenever I do that. So for next time, do that. Lower is going to be the balance divided by 12. The higher is the balance times 1 plus the monthly interest rate and the square root of 12 divided by 12. Epsilon, which is our placeholder, also kind of helps with the rounding. 0.01, the minimum payment is the higher plus the lower divided by 2. We're creating an object and using recursion. So it's our base case. And we're going to have the month balance, minimum payment, monthly interest. While the month is less than 12, it's going to add 1 to every month and it's going to keep recurring. It's going to take the remaining balance, it's going to equal the balance minus what we had or what our minimum payment was, which is the higher and the lower divided by 2. balance is going to equal the remaining balance plus the remaining balance times the monthly interest. So it's just adding that interest and multiplying it into that remaining balance, and it's going to return the balance. We changed this, which you could have honestly left it. This is lower, this is higher, and you would have gotten the same results, but help with minimizing. We're going to redefine that. While the month is equal to 0, the start or temp balance, that placeholder, it's going to use the recursion that we created here. If the absolute value of the temp is less than or equal to the epsilon, then we're going to break. And then if the temp balance is greater than 0, we're going to set the low payment to the minimum payment. And then if it's not, the high payment is going to be the min payment. Min payment is going to be the low plus the high divided by 2. The minimum payment, we're going to round it to 2 decimal places, and then we're going to print it as a string. And that's how that works. All right, thanks.